All right, we're throwing a lot of properties of exponents at you, but hopefully all these ones in the green should be familiar. Okay, these have all been ones that you've done before back in Algebra 1. So we'll still review them quick, okay, because you need to know them. But then the only thing that we really have new are common base and solving power functions. So really there's only two new things, but we'll quickly review all of our properties because you got to have your exponents down. And this is where we see a lot of trouble with little mistakes, are our exponent rules. So first thing, we got a product of powers. So when we take a product with numbers that have the same base, what do we do with their exponents? Well, x squared times x to the third really means x times itself 5 times. So what do we do with the 2 and the 3? We really added them together, right? Just like that. So when they're the same base, all we have to do is add their exponents. So if they have different bases like down here, I can't simplify those two guys. I could not add their exponents. Okay, so if we're multiplying, we could simply add their exponents. So 2 plus 3 gives us 5. Well, dividing, it's just the opposite. What do we do with their exponents? We subtract them. Okay, so notice that they have to have the same base. Okay, so if I had something like this, if I had 4 to the 8th power over 5 to the 6th power, I couldn't subtract any exponents. I mean, I could actually solve 4 to the 8th and divide it by what 5 to the 6th is, but I can't really do anything to just quick simplify that. But if I had like 5 to the 7th over 5 to the 4th, that's really 5 to the 7 minus 4, which is 5 to the 3rd, right? 125. So I could use that rule. The other thing with quotient of powers, what I like to do is when they have the same base, for example, like x to the 4th over x to the 7th, I like to just kind of cancel things rather than subtract. So if I look up top, I have 4 x's, where on the bottom I have 7 x's being multiplied. So these 4 x's cancel with 4 of these, which leaves me with 3. So this really becomes 1 over x to the 3rd. I prefer doing that rather than saying, x and then 4 minus 7, which is negative 3. And then I have to write it as 1 over x to the 3rd. I much rather just kind of cancel things with this property. Well, if we take a power to a power, well, what does that mean? It means I'm multiplying x squared by itself 3 times, which gives me 6 x's. So what do we do with the two exponents when we take a power to a power? We times them. So it's really x to the 2 times 3 power, so x to the 6th. So, for example, if I had m to the 3rd to the 9th, that would be what? M to the 27th. We just multiply the exponents. Okay, so there's the difference. If I would have had m to the 3rd times m to the 9th, we add the exponents, m to the 12th. Okay, so we just got to remember those rules. Don't get messed up with negatives, okay? Negative exponents are different than negative bases. So, for example, this first example says negative 4 times itself 3 times. So it's really saying negative 4 times negative 4 times negative 4, boom, negative 64. Okay, whereas if I take 4 to the negative 3rd power, that's really the same thing as saying, remember I can make this as a fraction to get the negative exponent positive. We move it to the bottom, so it's really 1 over 4 to the 3rd power, which is 1 over 64. Okay, and if I happen to take negative 4 to the negative 3rd power, well, get rid of that negative exponent first, so got to put it to the other side of the fraction. So that would be really what? 1 over negative 4 to the 3rd power. And what is negative 4 to the 3rd power? We already solved that. That's negative 64. So that becomes negative 1 over 64. So just be really careful with negatives. Remember, negative exponents are different than negative bases. And we already just kind of talked about that. What does a negative exponent mean? Think of it, it's like it's reciprocal, right? So if I had a fraction to a negative power, well, it just means it's flipped and it becomes positive, right? It's reciprocal. It just moves them to the other side, okay? Which that really just equals 3 halves. So if I had d to the negative first, it's 1 over d to the first, or 1 over d, okay? So if there's ever a negative exponent, it just flips it. So if I had something, like 10 over x to the negative 2 power, that would really be 10 over x to the that would really be x over 10 to the positive 2. Once I flip them, this changes to positive, so that would be really what x squared over 100, because I would give the square to both those guys, right? It's x over 10 times x over 10. Okay, so things like that, just tons of rules. We just got to remember them all. That's the tough part. Okay, and like we said, don't get mixed up, right? So in this case, if I took negative 2 times x to the negative 4, We want to get rid of this -4 and make it a +4. So remember, think of it as a fraction. And to make it positive, we need to move this guy to the bottom. So it should be -2 over x to the 4th. -2 over x to the 4th. Okay, same thing with this next guy. I just look at this, the 4 and the -5 as like a fraction. Can I simplify that? No, I can't. So I just leave it just like that. I can't bring this -5 up top because it's not a negative exponent. It stays right there. But what happens to this x to the -2? It goes to the bottom and becomes x squared. So I should have 4 over -5 x squared y to the 5th. And I put the x squared first just because we like to write things alphabetically. Okay, same thing over here. This negative in front of the 2 doesn't mean it flip-flop spots. It doesn't mean that. It's just saying it's -2 over -8. This is like a fraction I need to simplify. Well, if I simplify that fraction, I should get 1/4, right? A negative divided by a negative is a positive. Divide each by 2, so I should get 1/4. And then these guys really just flip-flop spots. So that comes down, and this guy goes up. So I'd have a to the 7th over a to the 4th. And then what happens to my a's? These 4 of these a's cancel with 4 of these, so I'd have 3 left. So really I should have a to the 3rd over 4. 1 times a to the 3rd, but I don't need that 1. Okay, so just a ton of rules, right? It can get confusing, so you have to be careful. Go slow. Take your time. Okay, don't be afraid to ask questions. All right, and then we also had power of a product, or power of a product and power of a quotient. And I already kind of looked at power of a quotient. Just know if it's all multiplication, we can give the exponent to each piece, right? If it's all division, we can give the exponent to each piece. If it's a combination of multiplication and division, we can give the exponent to each piece. So in this case, it'd be 3 to the 3rd, which is 27. It'd be f to the 5th to the 3rd, which we multiply, and h to the 3rd, which we multiply. So we should have 27 f to the 15th, h to the 9th. Can I distribute those exponents when there's a plus sign, like this, or a minus sign? Not a chance. Cannot do this. Don't do it, don't do it, don't do it, don't do it. I don't know how many times I've had to say that. Okay, and people still want to do it. This really means x plus 4 times x plus 4, which I have to go through my FOIL, and I'd get x squared plus 8x plus 16. So don't distribute exponents when there's adding and subtracting, when there's multiple terms. All right, this is the last time I need to say that. Okay, common base property, something new. This stuff's kind of cool. All right, so if they have the same base, right, if I have a and a, the exact same base, what I can do is I can set their exponents equal to each other. Okay, this is outstanding. This is going to be super helpful. So, and I'll show you what I mean with an example here. We got a bunch of examples. So if I had 5 to the 2x minus 1 power equals 5 to the 9th power, since they both have a base of 5, I can set 2x minus 1 equal to 9 and solve. So I can add the 1 over and divide by 2 and get x equals 5. And I could check it, right? I could plug 5 in here just to make sure. That'd be 2 times 5, which is 10. And 10 minus 1 is 9. So this would be 5 to the 9th equals 5 to the 9th. So it works, right? It does. It works out. Okay, it gets a little bit different when I get something like this. 3 to the x equals 27. Well, this one has a base of 3. This one has a base of 27. That's like 27 to the first power. Can I turn 27 into a base of 3? Sure, you got to think about 27 is really 3 to what power? So this is where it's going to take some thought process. Might even take your calculator to test some things. Yeah, that would be 3 times 3 times 3. So that'd be 3 to the 3rd power. So x would equal 3, right? I just set the exponents equal to each other. X equals 3. Okay, that one wasn't too bad. But what if I get to something like this? Okay, so this guy, 216, base of 216, base of 6. Well, can I get 216 to a base of 36? Well, let's think about 36 squared first of all. Well, let's think about 36 squared first of all. That's way more than 216, so that's not going to work. So I might have to get both these to a different base. So let's start with 36. That might be easier. Well, is there something times itself, like twice or 3 times it gives you 36? Yeah, 6 squared gives me 36. Well, can I break 216 into a base of 6? Let's try it. 6 to what power would give me 216? You know, this is where you might have to bust out your calculator. and just go 6 times 6 times 6. Test it 3 times. There it is. So 6 to the third power. So I'm going to replace 216 with 6 to the third power. You see that? So I replaced this whole number with 6 to the third. But guess what? That is still being taken to the x power, isn't it? Right? They got this x power right here. So I still need that. But what is that really? I'm taking a power to a power, so I just multiply the two guys. So I got 6 to the second equals 6 to the 3x power. Because now what can I do? I can set 2 equal to 3x, and to solve for x, I divide by 3, so x equals 2/3. Wow, that was kind of tricky. That was kind of fun, right? Something new. It's cool stuff. All right, all right. Okay, next one. Oh boy, now it's getting tricky. Okay, so I got a 1/5. I got a fraction, and then I got the 625. Boy, so I don't really want a fraction here. How can I get rid of this fraction? Well, let's think about 625 first of all. What base could I switch the 625 into? Could I do like 25? 25 times 25? No, that's not looking very good. What about 5? Could I take 5 times something? Right, because I got 1/5 right here, so that's kind of similar to 5. So could I take 5 to some power to get to 625? If I go 5 times 5, that's 5 squared. If I do another one, that'd be 5 to the third power. If I do another one, that'd be 5 to the fourth power. Oh, okay, let's try that. So let's write this as 5 to the fourth power. All right. Well, can I turn this guy into a base of 5? Well, how am I going to flip these two guys? How do I do that? What do I do to its exponent? To flip-flop them, I would just do what to the exponent? Make it negative. And 5 over 1 is just really 5, right? So it's really 5 to the negative x power. So now I have same base, so I could set negative x equal to 4. So what would x equal? Negative 4. Wow. That's kind of cool. Man, I like that stuff. Neato, neato. All right. If you have questions with that, that's okay. I'll give you some help. It takes a little bit of time to get used to. Yeah. Well, so far, we dealt with exponential functions the other day. Right, our stuff over here. You know, here was our start times our ratio to the x power. We can't solve these yet. Okay, we will. We'll do it next chapter when we get into our logs. But we can't do it yet. But we can solve a power function. We're going to be able to solve these bad boys like this when our variable is the base. Okay, if our variable is on the exponent, I can't solve yet. If the variable is the base, I can. And let's show you how. Okay, let's do a few examples. So I got 5x to the third power equals 70. Okay, well, I'm going to divide by 5. I want to get my variable by itself. So I got x to the third power equals 14. Normally, when I have like something squared, you know, we take the square root to get rid of it. Well, taking something to the square root, well, if I think about this, I really just need to get x by itself, or really x to the first power, don't I? That's what x, you know, being x by itself is really x to the first power. So how can I get this 3 exponent? What could I do to change it to the first power? Well, 3 times what would give me 1 anyway? 3 times what would give me 1? 3 times its reciprocal, right? And how do I get exponents to be multiplied together? Take it to another exponent. So what I can do is I can take this to the 1/3 power. Well, whatever I do to one side, I do to the other side. So I'm going to take this to the 1/3 power. Well, when I do this, I really get x to the first power, or just x, right? I really just get x there. Because if I take 3 times 1/3, I get 1. So it's x to the first power. And then I get 14 to the 1/3 power, which I just got to go to my calculator. 14 to the 1/3 power. Sometimes you need to put that in parentheses, depending on how your calculator does it. Mine puts it in all in exponents, so I'm good, so I don't need parentheses. And I get about 2.41. So I'm going to say about 2.41. Sweet. That was pretty neat. Okay, we should be able to get the hang of this now. So if I divide this guy by -8, divide by -8, I should get x to the 5th equals positive 12, positive 11.5. And then how do I get rid of that 5th power? Take it to what power? It's reciprocal, the 1/5 power. And whatever I do to one side, I do to the other. So x would equal, and then just go to my calculator again, 1.63. So nearest hundredth is probably pretty good for a lot of these guys. Yep. Well, same thing here. Get that variable by itself, so divide by 6, so x to the 1/2 equals 11. And then, well, how do I get rid of a 1/2 exponent? Well, that's really the same thing as this, isn't it? So I square it to get rid of it, don't I? And that should make sense because take it to the next exponent to be able to multiply. I take it over to the 2 over 1. So I would take this side to this second exponent as well. So that would be x to the, or equals 121. All right, hopefully we're getting the hang of this. And the last one here, divide by 7, divide by 7. So x to the -4th equals 3. Well, what would I do here? Well, I want -4 times what is going to give me 1? Well, it better be by a negative because I need a positive. And what's the reciprocal of 4? 1/4. Well, whatever I do to one side, I do to the other. So I take it to the -1/4 power. All right, so when I do -4 to the -1/4, that gives me +1 because I multiply, right? So x to the first equals, and then I just got to type that in. 3 to the -1/4 power. About 0.76. And there we go. Pretty cool stuff, right? So just lots of exponent rules, but when you think about it, you can do lots of new things now.